So we're going over functions as field vectors and how they can be, and their Lasso transformations, correct? So let's start with a little bit, which is something simple. Understand that, right? If you don't really understand this, I think it'd be good to bring up on the topic. Oh, sorry, I messed up. Vectors. Correct. So say in this case, let's draw a graph, right? You got two functions. We're gonna say here, right, 1 and 1, correct? And I don't know, it's gonna say we like 2 and 2. I don't know. Just pretty simple. So we understand that, right? What's going on here is that we're putting 1 in the x for each of the functions, correct? And it's gonna give us a certain amount of value, correct? So here we're gonna have, for this aspect of this, I'm sorry, we're gonna have 3 and 7. Sorry, vector. And then say this, so let's just make it simple, but just make it 1, 0. We're gonna have 2, 4, correct? So let's say we have 7 here. We have 1, 2, 3, 4. So our first point is gonna be 3, 7. And then this point is gonna be 2, 4. So 2, 4. Alright, so I'm not sure why I drew this for your graph, but we have vector here and vector here. Okay. This is in a two-dimensional vector space now. Now let's think about this in a deeper sense, correct? Or another way to think about it, right? We're gonna do something like this. So let's do it. Again, starting here. Where sorry, I know it's a little late, but we got this. Correct. Right. Given this and this, just put it in here. So I just want to be nice for my own remembering. Right? Or this on the chart, right? Just think, what is this? We have something where this square, let me make a square. The first amount is going to be 0, 1. Our outcomes, right, from this information, it's going to be here at 1, 1. Right? After what we do, correct? Let's say we have this function. What this gives us is an extension, right? So this is telling us that it's moving over, right, from the original, correct? And changing the numbers, like whatever, this x, y, right? But wherever we change the numbers and change. So say we change something where it gives us 1. Well, there's going to be a shift now. Say like this is like 1/2 or something. This will be a shift now where these numbers are going to move. There's a difference, right? It went this way a little bit because we're in the x-axis. It depends on what numbers we're going to use. But say you have 1/2, then it's 1. Now it's 0.5, right? So now you have 1 and then 1/2. Sorry, yeah. So then this will equal 1, and then this will equal 0.5. right? So then we have shifts, we're moving, okay? Now let's think about it in that's essentially what is occurring, correct? This number here is the X and Y, and this number is telling me how much we're gonna move side to side, correct? Now we can think about this in a three. You can think about this in higher dimensions, right? Correct? Where this can be x1, x2, x3. This is y1, y2, y3, and sorry, z1, z2, z3, right? Say we have some numbers moving around, right? As I mentioned, this number is you're moving side to side, right, in the x-axis, right? Whereas this number, you're moving in the y-axis. But when you think about 3 dimensions, say you just have where it's like you have a unit square, right? Where this is 1, 0, and this is 0, 1, and then this is gonna be yeah, so this is 1, 0, 0, 1, sorry. Right. Now we want to see what these numbers do, right? So these numbers produce shear in the x-axis. So let's say this is a cube. Right. This number, like I said, is moving x. This number is going up and down, correct? So there's, let's say it's at 1 and it's 2. Now we're gonna have to move up this way. This is on. Now we have to. This is 1. Now we have to 2, 0. So say that all the numbers are the same, then we have to move this way. Right, moving this way. But what are these numbers moving, right? Because this way, in this case, we're just moving this way, and it would have moved the other numbers, it would have moved that way, etc. Now we're in 3 dimensions, where the trimension has to be different, right? So these numbers create something that's called shear, where these numbers essentially are. This one is moving like this, and this one's moving. It's programming will help you, something like mathematics will help you explain a little better. But like example, this one, say this number change, right, in the x-axis, it will cause shear. And if you're not familiar with shear, let's say you have a square like this. Oh man, I messed this up. Right, say you're here. Shear causes the object to move in this direction. So now we're gonna have this, say like this. Right, you're moving in this direction, right? You're creating a bigger gap between this. It's called shear. Where say these numbers, say these numbers push off, right? These numbers are pushing off in shear off the y and the z. Sorry, these numbers are pushing off them, but it's moving in the x-axis, right? Same way as this number, if it was in the y, numbers we're changing the y, it's pushing off the x and z, and it's creating shear in the y-axis. And same as this way, and it keeps going, right? Because you start seeing transformations where things start bending or in a circle, correct? So we have a circle. If we're moving, in this case, say in the unit square, moving this direction, correct? And if it's going that way, if it's negative, say it's starting here, then if it's negative, then it's going this from the center this way. However, in a circle, say we have unit circle, correct? Things can change a little bit, where it says the center is here, and we have 1, and then here we have -1, correct? If these numbers move, right? It's like these x-axis, right? Where it moved, the end behavior would be moving. We're over here, right? We're circular. Say the numbers in this number is moving. This original number is moving, right? The numbers would move in this direction, right? Where the fields, the vector fields are moving in these, and say the rest of the numbers stay. Well, this will stay, right? Original is this one. But this one would move. This will cause it to move in this direction, right? A little bit different than this one because the squares start center out here. So then anything negative, sorry, if it was 0, it will make it. Sorry, if it was 0, it would make it collapse, right? Because we're closing. It's like we're closing in this direction. But once we're negative, then we pass the 0 and go into the opposite direction, which lead to something like. Drawn. Right, now we're moving in this direction, correct? And as in this way, right, when we're given a function and we say we have some numbers, it's telling us where the vector is going to be at, right? Correct? So saying we're giving a certain functions, right, and the values given here will have a geometric characteristics to it of what it's doing. It's not just numbers pointing in and out, right? It could be, if it's in a circular, it's going like this. It could elongate to the point where it's like, say this right here, now we're here, or it can shift like planes, right? Where it's gonna be like here, the shift is gonna be there, correct? But there's more to them than just the numbers going on, correct? And geometrically, there's more going on, right? There's a shift here. These numbers, they're all changed. Right now, I was given this, but they all change. It gives a difference, right? It leads to a different outcome. It leads to different behavior. What's being shown, and this is a little bit of introduction of how functions as field vectors and their elastic transformations, or a little bit of understanding of how the field functions as field can be seen as field vectors and their elastic transformations. Thank you.